All right, now let's actually use this polynomial of something that we want to factor completely. In the first section of this chapter, you were given some that were factored completely, right? In little terms, and they asked you about the multiplicity and everything. What we want to do is we want to take this big thing and list it as all of its potential factors. And we're going to use synthetic division to make it happen. So now I'm going to take this polynomial here, and I'm going to set it up for synthetic division by writing down all of its coefficients. We don't know which ones are going to work and which ones are not going to work. It's a complete guessing game. So if you have, if you have a pen, I encourage you to do all of this part in pen or pencil, doesn't matter. But do this part in pen, and then your factor that goes in the box and the rest of it do in pencil so that you can erase it and try it again. Okay? So we gotta pick a number to start with.
6.
6. Let's try it. 6, bring the 1 down. 6 times 1 is 6. Add on through. That's going to be positive 5. 6 times 5 is 30. Add that through. That's going to give me 11. 6 times 11 is 66. Add that through. That's going to be 115. 6 times 115 is, what we're looking for here is 30 in this very last spot. And I know that 6 times 115 is not 30. So that's not going to work for us. So 6 is out. Any other guesses? Yeah, you're a little gun shy. That's fine. I'm going to try 1. Bring down the 1. 1 times 1 is 1. 0. 0. Minus 19. Minus 19. That's going to give me 30. That's going to give me 30. From experience, just doing these homework problems, 1 is always a good candidate to start with. Okay, but that's just me doing these a lot. Now this is what you've ended up with. You started with a 5th degree polynomial. A 4th degree polynomial where you have x to the 4th minus x cubed, blah, blah, blah. What you end up with at the very bottom is another polynomial, and the way that you write it, just give me a different color. This is x cubed, x squared, x, and then the constant. So if you write out your answer, this is going to be your answer as x cubed minus 19x plus 30. But that's if we were going to stop here, right? But we don't. We want to factor this out completely. This is actually a nice thing about synthetic division, is that we can use this structure and keep going. And we're going to pick another number to put in the box. Now 1 worked once. It can work again, because we could have a multiplicity of 1. But I don't think it's going to get us there. I'm going to try 2. I'm going to bring down the 1. 1 times 2 is 2. 2 here. 2 times minus 19 is going to be 38. No, 2 times 2 is 4. And that's going to give me minus 15. That's going to give me minus 30. Give me a remainder of 0. Okay? I mean, I'm actually getting really lucky here. Sorry. So now what do you do? Well, you have two options, right? Well, option number 1 is you are left with x squared plus 2x minus 15 is equal to 0. You could go ahead and factor that using the techniques that we used way back in chapter 3. Or you can do synthetic division. Still. Let's try 3. 3 times, bring down the 1, 3 times 1 is 3. That gives me 5, that gives me 15, that gives me a 0. Okay? So now I'm effectively done, because what I have now is x plus 5 here. So what are my factors as my answer? Well, the first one is going to be x minus 1 from this very first divisor. Remember, we had to take our factors and set them equal to 0, right? So basically what we have to do now is our factor is x is equal to 1. I gotta subtract 1 from both sides to get that factor. The next one is going to be x minus 2. The next one's going to be x minus 3. And the last one's going to be x plus 5. And that equals 0. Because this is going to be your factor right here. So now I have my polynomials completely factored. Okay? What does it look like? Got a y-intercept of minus 30. What's my end behavior look like? Well, it's an even degree and it's positive, so it's going to start at positive infinity, do whatever it has to do, and end up at positive infinity, right? So my graph means that I'm going to start up here and end up over here. My factors indicate that it's going to cross at -5, +3, +2, +1. So it's going to cross at -5, +1, +2, +3. So to sketch it, I have to start up here, go through -5, go through 30, go through 1, go through 2, go through 3, and on up. Okay? Now, whether this is the actual graph or not is immaterial to me, because you can use a graphing calculator and graph it. Maybe this bends a little weird, maybe this is not the relative min, maybe it comes down and up and goes through. But what's key here is that, remember for the multiplicity part of it, is that if you had a factor of squared here, or the fourth, remember that graph bounces off the x-axis, right? If it's odd, it's going to go through.